Okay, we have a polynomial function, and we want to look at the zeros. Recall that a zero of a polynomial function is the x value where the graph crosses the x-axis. Okay, so we have zeros, x equal -2, x equal 1, and x equal 3. Now, a zero with even multiplicity is going to touch the x-axis. Okay, that means it's not crossing, it's going to touch it in reverse directions. Okay, a zero with odd multiplicity will cross the x-axis. Okay, so looking at each zero, x equal -2, the graph is going up, touching the x-axis, and going back down. So it has even multiplicity since it's just touching the x-axis. Okay. X equal 1. The graph is crossing the x-axis, so that means it has odd multiplicity. And likewise, x equal 3 is crossing the x-axis, so it also has odd multiplicity. Now, the way that shows up in the equation, if we want to write an equation for the polynomial function that might represent this graph, is that the power on the factor relating to this zero will be even if it's even multiplicity, and it's going to be an odd power if it has odd multiplicity. So a possible function for this graph, we know it's going to have a factor x plus 2, because if x plus 2 is a factor, x equal -2 would make it 0. Okay, this factor is even multiplicity, so it has to have an even power, since -2 has even multiplicity. So it could be a 2, a 4, 6, we're not really sure, but they want us to make the degree the smallest possible. So we'll just assume that it has a power of 2. Now, x equal 1 has odd multiplicity, so that means the factor that corresponds, which is x minus 1, has to have an odd power, so 1, 3, 5, 7, so on. So pick the smallest degree possible, so we'll use a 1. And likewise, x equal 3, the factor x minus 3 is going to have an odd power, and the smallest possible one then would be 1. Okay, so what we don't know is this leading coefficient. There's some number that's multiplied by that function, and it could be 1 or -1. They want us to assume that the leading coefficient is 1 or -1. If it was another value, it would just stretch that graph out. So let's see if it's 1 or -1 by focusing on the y-intercept. Looking at the graph, the y-intercept is where the graph is crossing the y-axis. And we can see from this, since every unit on the y-axis is 4, we see that the y-intercept would be -12. So let's plug in x equals 0 into our proposed function here. F of 0, we don't know the leading coefficient, would be 0 plus 2 squared, so 2 squared, 0 minus 1, so -1 to the first, and 0 minus 3, -3 to the first. When you multiply that together, you're going to get 4 times -1 times -3, which is a positive 12. But our y-intercept should be a -12. So this leading coefficient then should be a -1. And that gives us a y-intercept of -12. So an equation of a function that might represent this graph then would be this.